Well, it's easy to make up this type of problem. It's an exponential equation. Solve 4 raised to the x minus 3 equals 11 raised to the 1 minus 2x. I have no idea what the answer is going to be, but we'll find out. All right. Well, our immediate problem is that we don't have compatible bases. 4 and 11 are relatively prime. They have no common factors. They have nothing of that sort in common, so we can't approach this without ultimately using a calculator to get an approximate answer. So I can go about it knowing that we'll probably need a calculator. I can go about it by applying a logarithm to both sides. And our choices are common log, base 10, or natural log. I like to use natural log myself, but that's a matter of taste. And the reason to apply the logarithm to both sides is that the logarithm is how you can get exponents out of the exponents. So I'll show you what I mean. I'm going to take the natural log of both sides, and the power rule says that these exponents will multiply in front. So I end up with x minus 3 natural log of 4 equals 1 minus 2x natural log of 11. There we go. Now, this is a simple linear equation. The only way it's different from something you may have solved in beginning algebra is that we have some unusual coefficients. And if this was like a 2 and this was a 4, then this would be a real no-brainer to solve. But it gets messy with the logarithms. And rather than go to decimals, I really don't recommend pulling the calculator out at this point because you're going to be writing down lots of decimals. So I would approach all these symbolically until you solve for x and then punch that last calculation in your calculator. The problem with going to decimals at this point is not only do you have to write decimals, if you cut it off too short, then you're just going to create a very large error by the time you're done. And it'll be basically wrong. So, all right, I'm going to multiply through the parentheses. And we have natural log of 4 times x minus 3 natural log of 4 equals natural log of 11 minus 2 natural log of 11 times x. So I distributed through here, through both parentheses, just ordinary distribution. And the thing to bear in mind is these logarithms are just numbers. That's all they are. They're constant numbers. So I'm going to bring the x's together. And here's an x term, and here's an x term. So I'm going to add this term so that it appears on the left. And then I'm going to move this non-x term to the right by addition. So in other words, I'm going to get these to swap places. And so we end up with natural log of 4 times x plus 2 natural log of 11 times x equals natural log of 11 plus 3 natural log of 4. All right. So the x terms are together, and now what? Well, let's factor x out. So I have x times natural log of 4 plus 2 natural log of 11 equals to the right side. And now we're almost done. We can solve for x by dividing by this part here. I've run out of room, so I'm going to erase this part. And so we can finish up the problem. Okay, so x equals to natural log of 11 plus 3 natural log of 4 divided by natural log of 4 plus 2 natural log of 11. At this point, you can just enter it into your calculator. I would put these in parentheses when you do that. Because I'm me, I'm going to take a little shortcut here. I know that 3 natural log of 4 will be natural log of 4 to the third power. And 4 to the third power is 64. And over here, this is natural log of 4 plus natural log of 121, because 2 natural log 11 will be natural log of 11 to the second power. What I'm doing here is purely optional, but these are not bad multiplications. 11 times 64 looks like it's probably 704. So it's natural log of 704 divided, and 4 times, I just want to mentally check that, yes. 4 times 121 is, what, 484, natural log of 484. So what I did, because they were additions, I just multiplied and combined into single terms. There we go. So there's my calculation. It's short and sweet. Natural log. Now, because I'm dividing logarithms doesn't mean I subtract numbers. That's, don't confuse that with the actual quotient rule. All right, so we have natural log of 704 divided by natural log of 484 is approximately 1.06. So x is approximately 1.0606. All right, so I went to 4 decimal places. There we go. Now I'm going to check that answer. And I have all the decimals in my calculator. I'm going to store it as x. So if you have a graphing calculator, you can store answers as a variable and then just punch in the equation. If you don't have a graphing calculator, you can still do that with memory key, but it's a little harder. Alright, so 4 raised to the x minus 3, close parentheses. And then I'm going to subtract this to see if I get 0. So subtract 11 raised to the parentheses 1 minus 2x, close parentheses. And I get, when I take this term and subtract it from this, I get negative 1.6 times 10 to the negative 14th power. 10 to the minus 14th power is about 0. So what I'm seeing on my calculator is a round off error. In other words, the problem is correct. So within a little tiny minuscule round off area, this is good. All right, so there you go. If you're a lot more comfortable punching this in, that's fine. Just be sure to use parentheses there. Otherwise, you could really screw up your calculator. If you don't use parentheses and hit divide by this and then add this, your calculator is not going to interpret it the way it's written. So, and you'll get a wrong answer. So I'd be careful about that. Okay, I'm going to go on to another exponential equation of a different sort. Here's our equation. Solve 3 to the 2x plus 3 raised to the x plus 1 minus 10 equals to 0. All right, now if you've never seen one like this and you just approach it blindly the first time, it could be very, very tricky. And because here you've been doing these exponential equations and logarithms, and suddenly you're confronted with this mess, and where in the world do you start? Because we have a 10, which has nothing to do with 3's. We have powers of 3 that are variables. It's all very strange. So I thought it would be good to work one of these. And the secret is that this is a quadratic form. And you studied quadratic forms earlier in the quarter. And the secret to this one is to force it into a quadratic form where this is the squared term. If 3 to the 2x is a squared term, then the variable you're going to work with is 3 to the x. Now I don't have 3 to the x here, I have 3 to the x plus 1, but this is 3 times 3 to the x. Because my exponent here is 1, when I multiply these together, I add exponents, it becomes x plus 1. So I took that out of here, and now you see that I have a 3 to the x, I have that term squared, and I have a constant. It is a quadratic equation form. And I'm going to factor with 3 to the x. So anyway, that's kind of tricky. I'm not too, these are kind of fun, but I'm not too wild about them as practical use. But they do appear in your textbook, and I suppose there's some value to them. All right, now to factor, 10 is probably going to be 2 times 5. And to get a plus 3, I need a plus 5 and a minus 2. So you might take a minute here to confirm what I've done actually works. When I multiply these together, I add their exponents, so I get 3 to the 2x. Here I have 5 times 3 to the x minus 2 times 3 to the x. 5 minus 2 is 3 times 3 to the x, and then minus 10. So it did factor correctly. And now I need to set each factor equal to 0 to get the roots. 3 to the x minus 2 equals to 0, and 3 to the x plus 5 equals to 0. All right, now one of these has no solution. Do you see it? Have to be this one, because 3 to the x is a positive number. A positive number plus 5 equals to 0 is impossible. Or if you think of another way, put the 5 on the other side, you have a exponent function 3 to the x equals to a negative. That's also not possible, because 3 to a power, regardless of power, is always a positive number. So I don't even have to fiddle with this one. That gives us no real answer. Over here I've got 3 to the x equals to 2. And so if we go to, let's see, how should we solve that? Well, we could go to logarithmic form, and x would equal to the log of 2 base 3. Okay, but then you could use the change of base formula. This would be natural log of 2 over natural log of 3. So that's one way to get that one there. So, all right, we have an answer. X equals natural log of 2 over natural log of 3, which is approximately, and let's see what that is. It would also be log log 2 over log 3, common log, it doesn't matter. Natural log 2 divided by natural log of 3 is about 0.6309. 0.6309. Alright, so there's the exact answer and the approximate answer. I'm going to check my answer in the original problem. So I'm going to store that answer with all its decimals into x. And then 3 raised to the parentheses 2x, close parentheses, plus 3 raised to the parentheses x plus 1, close parentheses, minus 10, hit equal, and I got 0. Came out to be 0. So that's a good answer. And there we go. All right, on to the last video of this section, which is about a special function.